questions below, and I'll respond quickly or in the next episode of Louis.
Woo! It's hot outside. I shouldn't go outside when I'm wearing a suit, especially at this time of year. Okay, gonna get ready right here. Looking at the schedule of all the events. We're gonna do some My Pearson Chapter 7, I think. We should be streaming online, I think. Office hours, that's old office hours. Where's current office hours? Current office hours. Gotta cool down here. Too hot. Is anyone in the chat? I see some people here. Or see Tito, former student. Hey, good to see you there. Hi. Hopefully I've said hi. I'm pulling up the chat as we're speaking. It's so hot outside. I shouldn't have gone outside. I should have never gone out. Never go outside. Rule of life. Stay indoors at all times. Good to see you. Glad you're still a mod. Thank you for swinging by. We're going to throw you some points. We'll see if Mubot's a way to throw points. So there we go. Live chat. Oh, Mubot's saying hi in the chat. Look at that. Mubot's still here. So we got Mubot in the chat. We are good to go. And going to start doing some stat. And someone liked the stream. Thank you right there. Reptar, do you want to do some Chapter 7? Reptar, good to see you there. I was helping some students from NC State find the student union and find some food. They're like, Brian, where do we go for food? And I said, student union, where it's at. And they said, can we get an acai bowl? And I said, you bet we got those here at UT. Because we got everything here at UT. So shout out to those students visiting from NC State, Raleigh, North Carolina. Good place. My brother went to NC State. So exactly. Have some refreshers right here. We're gonna do some analytics, some statistics here. My phone's buzzing. It's saying I got class in an hour. I got class? Got class coming up. Okay, Chapter 7. People have been working on the homework. Some people have started up. Let's get the quiz up, though. Some people in class are asking about the quiz. I think we have enough time to do a lot of it. How much can we get done in about 40 minutes? Let's find out now. We're going to go to, whoa, it's a lot of questions. Okay. Let's start from the very beginning. A very good place to start. Hard question to start. Okay, we're going to do as much as this Chapter 7 quiz as we can possibly do. This is a harder question to start. Or it's just got a lot of parts to it. It's not hard. It's just a lot of parts. So this is Stat 201 Chapter 7 quiz. And the quiz is going to be the manager at a bookstore. Now, what you need to do with these questions right here, if you are given the data, is you have the summary statistics below, meaning the mean of X, the mean of Y, just the average of those values, the standard deviation, which is variation in X, variation in Y, and the correlation. You also get the variables right here, the data, the individual points, and we can copy them by going to this part and going to copy to clipboard and doing Control-C or Command-C. Now, we're not going to solve things by hand in this class because who has time for that? We're going to go over here to the Regression Solver Pro, and the Regression Solver Pro can be found under the modules. So you can enter in the summary statistics here, which is the correlation, the standard deviation of X, standard deviation of Y, vice versa, and the mean of X, mean of Y. I'm going to paste the data here, and let me show you where to find the Regression Solver Pro. The Regression Solver Pro can be found under the modules in your class. You need to go to your class and go to the modules. I'm in 475 right there. That's a different class. Different class, different modules. So we're going to go over here to Stat 201 with Brian Stevens. And on Stat 201 with Brian Stevens, we're going to go to the modules. And underneath the modules, you will see under Chapter 7, the Regression Solver Pro created by me, Brian Stevens. Hey. So you want to open this up, and when you put in your data, you need to not cover up this X and the Y. A lot of people make that mistake. You need to make sure the Y is the variable of interest. We want to understand sales in thousands of dollars. So what I did was I clicked up here, and then I held Shift, and then I clicked the bottom one, and I clicked Control-C, and then I click here, and I paste. Then I click here, and I hold Shift, and I hit Control-C, and then I go over here, and I click Control-V. And now look, all the answers are on the screen. So this will solve for you the intercept, the slope, the correlation, which we don't need. It'll also get the other values, which are summary statistics, which are given to you in the problem. And you can also use it to input values like, what if we had 9 workers? Now, that is the predicted amount from the regression equation, where, once again, you have to know the regression equation is going to be written out the following way. The regression equation is predicted sales. So it's predicted sales is equal to the intercept, 9.344. And that's where we're grabbing this. This is B0, as it says. And then it would be plus 0.7482 times workers. So this is the regression equation here. To make a line, you would just simply put the line through the data, and the intercept is down here at the bottom. So the intercept is going to be this value, and then the slope is going to be this 1 unit change right there, which is that for each additional worker, we would expect the sales to increase by 0.74 in thousands of dollars on average. When there are 0 workers, which is when X is equal to 0, we expect the sales to be 9.344. So once again, the Regression Solver Pro finds the answers. Now we just need to input them. I'm going to bring this over here to the side where I can see it. You'll once again need to use your numbers. This is to how many decimals? 3 decimals, 0.748. And that means on average, an additional increase in sales is associated with each additional person working, I think. On average, an additional increase of this times $1,000 in sales is associated with each person working. The intercept is when X is equal to 0. So that value is 9.344. And this means when we have 0 people working, the predicted amount of sales. It means that on average, the expected sales is this with 0 people working. This is unlikely to be true because if 0 people are working, we make $0. Going a little quick, but I think we've got it. On average, an increase. No, it's not an increase. That's slope stuff. Intercept is when X is equal to 0. So now simply take your value as we did of the intercept, goes there, that's B0, and the value of the slope goes down here at B1. So there's the regression equation. To figure out the next one, it says if 16 people are working, so we have 16 people working, what is the predicted sales? So all we do for this is we go in here and we simply plug 16 in. That's just going to solve out the equations. Let's go grab our handy dandy calculator. And on the calculator, we're just going to plug 16 into the equation. So we go here and go 16 times 0.748. And then we add to it the intercept, and we get the predicted sales. That's why it has a little hat on it. That means predicted sales. So with 16 people working, we'd predicted we'd make $21,000 about. And here's the thing. It says round to the nearest $10. So I've done this improperly. It is in thousands of dollars. So we need to times it by 1,000 and round it to the nearest $10, which means when we round this, if we look at it, it's going to be 21,310. Why they do that? No one knows. It's actually this. Now, this gets into the idea of a residual. So a residual means the actual minus the predicted. A quick way to remember residual is to do residual wrap. Residual equals actual minus predicted. Sometimes people call this the observed or what you see. So we actually saw 22,000. We predicted 21,310. If you notice, the actual is higher than the predicted, leading to a positive residual of 690 if you subtract the two numbers. What this means is here's our regression model, and the point, which would be this right here, is above the model. And how much is it above by? It's above by 690. I should maybe do this in a different color, because the amount in units it's above is 690 units above. So it's 690 units above the prediction of this right here. So that's the prediction from the model. And that's got it. And this would be at an X of 16. So we could write down here to finish our graphic at salespeople equals 16, which is going to be right there. And that's where you would predict it to be 21,310. And it's actually 2,200. Now, this is where a lot of people make a mistake. This is the answer here. The residual is that. And it's positive because it's above the model. Now, the model is under or overestimating it. Well, the model is under the point. So it's an underestimate, 690 an underestimate. We should have 100 unless I've made an error. I think I did the math right in my head for that one. Let's double check. Never hurts. So that has to be 21310. And we do actual minus predicted. There it is. And the model has underestimated it. We got 100. That's one of the, if you can do this problem, that's one of the tougher ones. It's just finding the equations a lot of times and making sure you do the right interpretations, but it's a good one. Now we get to a much easier one. Much easier. Just kind of a straightforward one. I think I did miss this one last time I did it, though. So let's get it right this time. This one is about r squared. R squared is the percent of variation in y explained by the variation in x. Now, what I ask that you do is not look at their interpretations. This one's the same start. This one would be regression line. Okay. So r squared is blank percent of the variation y is explained by the variation in x. They kind of do that here. Well, the manager is going to want to predict sales. That's the y variable of interest. We call it the y variable of interest because we're interested in it. It's the response. It's what we talk about. The x is the explanatory variable right there, which explains, sales explains why people make so much money. Or salespeople, excuse me. And so with this, we think, what is the r squared? The value of r squared can be found by squaring r. It's the formula for it. So you take r right here of 0.964 and square it to get r squared. And then you times it by 100 to interpret it. Mubot is going to put for us in the chat right here a generic interpretation of r squared. Just make sure it times it by 100 because it is a percentage. So blank percent of the variation in y, or 92.93% of the variation in y, is explained by the variation in x. They kind of do it right here, so we need to, we'll just do 92 point, does it say that one decimal, so 92.9, 92.9% of the variation, we just did in the calculator, yeah. 92.9% of the variation in the sales, not number of salespeople, so we've narrowed it down to these two because it's 92.9% of the variation in sales can be accounted for by a regression model of sales on salespeople working. So that's y on x. So blank percent of the variation in y can be explained by a model with y on x. I wish they didn't do that. I'd prefer 92.9% of the variation in sales can be explained by the variation in salespeople. There we go. Blank percent of the variation in y is explained by the variation in x. Another question. Watch us do all these. We're speed running this today. Chapter 7 quiz. Disk drives have been getting bigger and bigger. Have been getting larger. Okay. Disk drives have been getting larger and larger. Their capacity is now often given in terabytes, which is 1,000 gigabytes, or often trillions of bytes. We don't really say that. We say 1,000 gigabytes. A survey of prices for external hard drives show the following data. What is the value of r squared? So they don't give us the r squared. This means we're going to the regression solver. If you didn't see it at the start of the video, the regression solver can be found on the Canvas page. You need to go to the modules on your Canvas page and scroll down here to the regression solver under chapter 7, and you will see the regression solver. Now, when you start out the regression solver, which I have on the other screen from our previous problem, it won't have data in it, which you don't want data in it to begin with. You want the regression solver to be blank, and we're almost back to where the regression solver is blank. Well, I can't go back in time that much. You can only go back in time so far. Lesson for us all. So now you have the regression solver loaded up. This is where you put in summary statistics, like if you were given the correlation, given the standard deviation, you'd put them in there. But we are given data. So with the data we're given, we're going to go over here to this button to copy it. Then we're going to click Copy to Clipboard and click Control-C or Command-C, Mac versus PC. Then go over here and just paste it to the side. I do this so I can figure out where the data goes. If you look, we want to predict what the price is. So click on the top, hold Shift, click on the bottom. Copy with Control-C or Command-C. Then go over here, click there, do not click on the X, and paste. Now the data is in for the X. Do the same thing by clicking the top number, holding Shift, and clicking the bottom number, clicking Control-C or Command-C, and then clicking over here and clicking Paste. Now, take a look. We've done it. We have the intercept, we have the slope, we have the correlation. So how do we get r squared? That's about as strong as a correlation I've ever seen. You could just go here and say equals this times this. I mean, we're in Excel, so let's just use Excel, right? And there's the r squared. Man, that's a crazy r squared. 99.9% of the variation. Could be due to some outliers or something, because outliers impact anything, as they always say. 99.91 or 99.92% of the variation in the price of a hard drive is explained by its size. Round to two decimals, 99. That's as... So the value of r squared of 99.92, I hope I didn't do something wrong, because that's about as perfect as an r squared as you get, indicates the percent of variability in y, which is the price, of these hard drives that can be explained or accounted for by a linear model on the hard drive's capacity, because price is being explained by capacity. I think we've done everything. There you go. It's about the highest r squared I've ever seen, and that data must be about perfectly on the line. We talked about this a lot during class today. I think I drew a model back here of what an r squared of 1 basically looks like. The line could go up or down, rock knows. It doesn't matter. I drew it today, I swear. Maybe I drew it on a little side thing. but we talked about an R of 1, and you basically have a perfect model. So you only really see perfect models when you get an R of 1. Oh, there it is. Here's the slide I drew it on. So you have to have all the points perfectly on the line, and it doesn't matter if the line goes up or down because it's R squared, and R of 0 means the line accounts for none of the variation, and R of 1 means R squared of 1 means it accounts for all the variation. And R squared is not correlation. Correlation is just R. Okay, got another R squared one. We're going to do the full quiz. I'm gonna tell people, I did the full quiz. They'll say, I'm never coming to office hours again. You'll do everything. Come to office hours. Get some points. Come to office hours. A student in an intro class like you. How topical, my Pearson. How topical. A student in an intro statistics class is doing something where they're figuring out the relationship between student jobs and GPA. They collect data figuring out how many hours they work and what their GPA is. They find an R squared of 12.7. So you think, what do they want to understand? They probably want to understand people's GPAs. That seems like if you're a student, you're not like, let's understand how much people work. You could, but with GPA in the mix, GPA is usually what students are going to care about. So that makes that the Y variable of interest. Remember, the Y variable is the one we care about. It's the variable of interest. So we think the Y variable being GPA, we want to understand or explain GPA by the variation in hours of work. So 12.7% of students' GPAs can be accounted for. This seems about right. I don't love it. 12.7% of the changes. Yeah, because that's the only one that does. It's just between these two when you realize the Y variable of interest is GPA. It's not whether or not a student works. It's based on a linear model. That is probably, and I hate to say this, one of the worst interpretations of R squared I've ever seen. 12.7% of the variation in GPA can be explained by the variation in how much a student works. Blank percent of the variation, look in the chat, that's already written in, blank percent of the variation in Y can be explained by the variation in X. They try to give you different alternative ways of saying things, and I didn't like that. No, sir. We've got a nice and easy one here, too. This is just using the model to make predictions. So we're putting the note, hey, Reptar, it is. Yeah, the way they phrase that, just remember it's blank percent of the variation in Y can be explained by the variation in X. This one is a prediction model. See if you can get a Reptar. All you're doing is using the equation right here to predict how much potassium the cereal will have. So what do you do? What do you do when it says use this equation to predict how much potassium? Now, it's not how much potassium it actually has, but it's saying if you buy a cereal with 9 grams of fiber, then what is the predicted potassium? You're like, this cereal has 9 grams of fiber. How much potassium do I think it would have? What is the predicted potassium? Predicted potassium. There's like 2 drops left in here. What is the predicted potassium? Predicted. Predicted. Well, what we do is we just take 9 and drop it into fiber. No worries. No worries. Let me take 5,000 points. So what you do is because we're predicting potassium and it's 9 grams of fiber, so you plug it in. If you think right here, it's going to be, I think, 289. Let me think. Did I do the math right? I did it really quickly in my head. Do I know how to math? The answer is I do. So once again, we're just going to plug into the equation 9. So just imagine right here where that fiber went. You plug in 9. 9 times 28. There you go right there. And then you add to it 37. There we go. There it is. So all you do when you predict, you use this value of fiber in the equation, making it, yeah, the points are awesome. T-Dub, did we have Mubot here when you were in class?
T-Dub, did I exist? Were you here with Mubot? And could I talk to students?
Was Mubot here? Skeletor always likes when Mubot appears. So, got so many points. Good to see T-Dub here, grabbing some points. Not then. We've made some advancements. We've done some new things. Oh, wait, look at this. It's predicted miles per gallon. So how are we going to solve this? Reptar, how are we going to solve this equation where we have to predict the miles per gallon? So what are we going to do? If the car has a 5-liter engine, I'll take the note while you tell me how to solve this problem. It's around 20. Wow. Oh, dude, TW, you're here at the start of this. I should play, if you hang out or you check out some of the videos, or I'll play you something here in a moment. But we have so many new things. You were here at the start of this. You might have been here for the COVID semester, but this class has gone through a lot of new things, and I'm honored you're back checking it out. But COVID changed a lot. Yeah. And this class has gone through a lot of updates, and we try to make it as fun and enjoyable as possible for students. So, yeah. I bet we didn't even have Crash. It's been on a while. This might be a 2021 thing. It's not Wacky Wednesdays, though. I need to do it more often. On him with that much. Reptar for 5,000 points. You got it. I just hit the wrong button. Reptar for 5,000 points is right. All we're doing right here is we are just plugging in. Maybe around that. We're just plugging in this 5 into the equation. And that will solve for the predicted miles per gallon. Not what it actually has, but this is the, with an engine size of 5 liters, we multiply it by 3.8767. Now make sure to remember, and Reptar did it, it is negative. So we're going to take 36.91 and subtract that amount to get the predicted miles per gallon. That's what the equation predicts to 1 decimal. Really? Why do you ask? Why do you give more decimals if you don't want them? So that is that one. We're rocking and rolling right here, doing a bunch. Another pretty easy one. So let's just destroy this question. Okay, this question is trying to figure out about the predictions. Let me mark it here. 2313. All these easy questions that I never do because no one ever asks these ones. No one wants to do the one. For many people. It's the same thing. Part 2. Okay. We have a regression equation right here. For this model, you can estimate a cereal's potassium content. That's what the model is doing. It's estimating potassium based on fiber. In this context, what does it mean if it has a negative residual? When you hear negative residual, you want to think the point is where to the line. If a residual is negative, where is the point to the line? So think about, here's the line. Where's the points if it's negative? Hey, William. If you have time, maybe we look at some BS review. Oh, yeah, we'll try to do that right here. Yeah, thank you, William. I'll do a question. We'll do one more of these, and then we'll do a BS review. If it's a negative residual, where is it? This actually applies, William. Actually, we might just check out these questions apply. I'm gonna try to turn these into BS 320 reviews. So what does it mean for someone to have a negative residual? This is good because this is regression. This is what 201's covering. So what does it mean if something has a negative residual? I'm going to turn all of these questions into BS 320 questions right now, which is a bigger class on this topic. Something that has a negative residual is underneath the line. Positive residuals over the line, 0 residuals on the line. So think about this. This means that the actual potassium is lower because this is the actual and it's over predicted exactly. I'm gonna try to make some if I gotta finish writing the test tonight, I'm gonna try to make some questions out of that. So it's lower than predicted by the model when it has a negative residual. Let's see the next question here. Okay, so this is another prediction. We're doing a bunch of easy ones. I'm gonna turn all of these, William, into like a 320S question. I'm gonna ask, like, I'm gonna be thinking over because you get to like get my thoughts on the test. I'm gonna test tomorrow. Okay, so this question is 2513. It's the perfect time because this is chapter 7 regression. And all these questions sound very similar. With this right here, explain what the slope means. So William, this is where your class might have a slightly different interpretation. So William, try to do the proper interpretation, which is on your test, of the slope in the chat. 201 has a more generic stats interpretation. 320 has the exact what it means perfectly in the real world, where we get very precise with our wording and we're very careful in the business sense. 201 gets the more general stat interpretation. I would change it if I could. I would change it. People would say, what in the world are we saying? That's what they say in 320. So what is the interpretation, William, of the slope coefficient? Now, when we have a regression model, we have to identify the components of it. So William's going to try in the chat to give the perfect interpretation of a slope coefficient for 320 classes. So that's going to be a little more advanced. This is predicted potassium, y hat, is equal to the intercept plus the slope coefficient times the x variable. So very clearly the slope is 28. But William, how do we interpret it? I'll do the 320 and I'll do the 201 interpretations when we say them. Anyone take a guess? If you're in 201, give the 201 interpretation, which is, it implies a little cause and effect. And in 320, we get very precise with our wording. Like we're in a business meeting, we have to be very exact. Who has a guess? I'll give it another moment. I'm gonna give the exact 320 interpretation, William. Can you do it for this, which is on your test? The exact 320 interpretation of this. Mary, 320 does get a note sheet because their tests are more difficult and they're all written. Pure written test. 10 written questions. Pure written. Any guesses? Give it another moment more. People might be typing. But William, remember, that is cause and effect. That is cause and effect. We don't want to use will. And don't worry, William, only 35,000 points. We don't want to use words like will. Check out, I'm going to go to the 320 notes really quick. Check out the 320 notes. It's a little bit more of the 201 interpretation. So 201 does it slightly different. The notes on 320, we want to go to the regression notes. And definitely use these right here, simple linear regression part 1 notes. I'm pulling them up as we talk. And you want to go to these notes. They're opening up. Okay, here we are. Here we are. And we go down here. Of course, it's like not fitting to the screen. Here we go. 2 blanks that differ by 1 blank or 1 unit of x are expected to differ by blank units of y, where the higher one is expected to have higher if it's higher. So this is our interpretation in 320, and I want to tell you what it would be for this. So with this equation, it would be the following. And William, you can take a shot if you want. William, thank you for trying right there. And Reptar, if you want to answer 2, you could do the 201. The interpretation for 320 for this will be 2 cereals that differ by 1 gram of fiber are expected to differ by 28 grams of potassium, where the cereal that has more fiber is expected to have more potassium. Watch out for words like will, because will implies cause and effect. And notice we're comparing here, because in the model, which I can't draw on the screen right now, in the model, you would have 2 cereals, and this slope right here is the expected difference between the cereals, where a cereal with 1 unit higher fiber is expected to have 28 more potassium. So 2 cereals that differ by 1 gram of fiber are expected to differ by 28 grams of potassium, where the cereal with more fiber is expected to have more potassium. And a very vague, quick generalization of it would be cereals with more fiber are expected to have more potassium by 28 grams. I'd probably accept that, but you can go more classic, like 2 cereals that differ by 1 gram of fiber are expected to differ by their gram of potassium by 28 grams, with the cereal that has more fiber is expected to have more potassium. If they want it quickly, you can just say, generally we see cereals with more fiber have more potassium. Usually a 1 unit increase in fiber is expected to have a 1 unit difference of potassium, or you get it. Just repeating myself. The model predicts, so we got to have the slope. It's one of these 2 for each additional gram of fiber. So that's going to be right there. So for each additional gram, and this is the 201 interpretation, which it makes it sound a little too cause and effect. It's more about 2 cereals that differ. And the best way to do this is talk about things like height and weight. It's not for each additional pound. Yep. So make sure to write those down really good. And that's a great review question. So what does the slope mean in this? Can you do it right here? So the slope, first thing in interpreting the slope, this is interpret the slope, right? Who can interpret the slope in the chat? Can you interpret the slope? Well, do you have a 201 or 320 interpretation of the slope here? Who can interpret the slope for this one? Try to interpret the slope. Well, the last one was analysis, too. Oh, this is analysis of relationship. And this is fuel. Analysis. Interpret it in the chat. Give it a shot. Don't worry if you're wrong. Just, you only know if you're wrong if you try. This is CombinedMPG. The last one was fiber, or potassium fiber. Anyone got to try it this one? So I'm going to do the 320 first, which is not, well, let me wait. I'll do the 320 second, and then I'll do the 201 first. This is the 201 interpretation, which is a basic general stats interpretation, which we'll use. 320, 327 honors. We go much more in depth and very precise on what it means. The 201 general interpretation is, if you do a 320 interpretation on your test for 201, they should accept it. If they don't, you should talk to your instructor and be like, that's very precise. You can always be safe and use the 201 because we all teach to a general audience. But business analytics, we go, business analytics, we're going to be very exact. We just, we'll lock it down. Anyways, you get it. So with this right here, the 201 interpretation is, for each 1 unit increase in displacement, we expect the combined miles per gallon to decrease by 3.318 on average. We'll find which answer that conforms to here in a moment. The 327 perfect interpretation is going to be Two cars that differ in their displacement by 1 unit are expected to differ in their miles per gallon by 3.318, where the car with a higher displacement is expected to get lower combined miles per gallon, because you're comparing two cars. Well, these cars differ by 1 unit of displacement, so I would expect their miles per gallon. Expect, remember, keywords expect. So the model estimates that cars, it's ridiculous. It sounds cause and effect. So the 0 is interpreting the intercept. We're not doing intercept. The model estimates that the car, so it's going to be one of these. And engine size is that right there. So engine size is displacement. So this should do it. It's not like the engine grows in a car, but for each additional 1 unit increase in displacement, we expect combined miles per gallon to decrease by 33.467 on average. There you go. Stat 1 interpretation. Okay, we got a what is an R squared or so. Any questions in the chat? Will, is this making sense, William? Like with these sorts of interpretations? R squared is used for what? Good 320 question here. R squared is used for what? R squared is used for what? R squared is a very important component of what? So far, so good. Nice. R squared is practical significance. Do we care about it? There's no measure, there's no amount of R squared that means we care. The higher the R squared, the more we understand in Y based on the X we understand, or our understanding of X. So you generally want higher R squareds. Too high of an R squared would be maybe overfitting, which we briefly mentioned in our class. But to get R squared, you simply take R and square it. And then R squared is interpreted as a percentage. So round to the nearest tenth, that's going to be 83% when it all rounds up. So 83% of the variation in a cereal's potassium can be understood by the variation in its fiber. And that is a 320-201 interpretation. So 83% of the variation in potassium can be understood by a cereal's fiber, because we want to predict potassium. That's what we want to understand right there. So use square R to get R squared. And another R squared, well, man, these R squared ones are easy. I mean, it's the same thing. Someone clicks this. I'll just do it because it's, yeah. Now, R squared, this shows you that R squared cannot be negative, because when you square R squared, you don't square R squared. When you square R to get R squared, you don't have to put in the negative, because it's going to square away. And then you multiply by 100 to turn it to the percent for the interpretation. So 59.6% of the variation in the engine size, or 59.6% of the variation in fuel economy, can be explained by the engine size of a car. So once again, the fraction of variability in Y that is explained by X. Make sure it's blank percent of the variation in Y is explained by X. We got pretty darn through this right here. We're on question 12, and it's another R squared question. Can we do 2 more questions? How are you feeling on this, Reptar? Is this starting to make more sense? We've just been going through these questions really quickly. I hope people are understanding, but a lot of questions, trying to make it, weave it into 320 and 201. So, all good. I'm glad to hear that. So this is R squared, blank percent of the variation Y is explained by the variation in X. So you just take a look. Well, it's already squared. Don't square to square root it. It narrows it down to 2 answers, because a linear model on, I hate that it's saying on, that means on X. When you think about on, we won't put that word on the test. Your model is on X. Think about it's on top of it. I don't know. I don't use that wording. But that means a linear model on X. So the X variable is going to be the size of a home, accounts for the variation in Y. Remember, we're trying to understand Y. So I would say 74.2% of the variation in price is explained by the variation in the size of a home. 74.2% of the variation, I would say, once again, 74.2% of the variation in price of a home is explained by the size of a home. I think that is a much easier way to understand it. Blank percent of the variation in Y is explained by the variation in X. Blank percent of the variation in Y is, and this might be a good one for us to finish off, because we're running out of time, and I got to eat a sandwich. I got to go to class. Got to be there on time. Okay. These are residual plots. Really good question right here. Residual plots. Tell what each of the residual plots. You're welcome, T-Dub. Thank you for being here. We'll do some outro here in a second, but we appreciate everyone being here. So a residual plot, we talked about this a lot today in class, should show no patterns. We drew some over here. And here is, where's our full residual? Here we go. So this is a perfect residual plot here created from this plot. To create a residual plot, you simply take your line, this red line here, and make it flat and set the line equal to 0. Anything on the line, like this blue dot right here or this green dot, which are very close to it, would have a residual at or near 0. Points above the line have a positive residual. Points below the line have a negative residual. And a residual plot is meant as a diagnostic way of looking at the plots so you can see what's going on. So you simply take the line and you make it flat. This is a perfect 10 out of 10. This one shows extreme plot thickening. All you do, once again, is take this line and make it flat and set it equal to 0 to make it a residual plot. A residual plot is what it says it is. It's a plot of all the residuals. So you can see that this yellow dot right here is about, I don't know, 12, 15 above the line. That's how far it is above. This dot is like 2 below the line. It's just -2 on its residual because it's below the line. So you don't want to see any patterns. It should look random. And that's a good thing. People think if it looks no pattern, that's bad. Remember, it's a residual plot. It's not the plot of your data. So what's this plot show? It shows a bend. Bends are bad. That's a nonlinearity to it. So the curve pattern shows that that this is a nonlinear model. This shows a fanning out pattern, and if it's fanning out, it's getting weaker, as in the points are getting further out from the model's explaining them less. So the fanned out pattern indicates it's not appropriate. That's an issue of plot thickening. So the model's predicted power is decreasing as the modeling goes on. Decreasing predicted power means weaker model. It's decreasing in its power to predict. This is another nonlinear model right here. The curve pattern shows nonlinearity. And there we go. Let's see. I think the next one's the same. This might have an outlier. They're calling that an outlier. That's a weird plot. This is definitely an outlier. You can see outliers in residual plots. Remember, it's just your line is flat and the point would be away from the line. So this indicates, except for one point, the outlier, and then we have 2 nonlinear models. So I really like these questions. Residual plots are often looked at by statistical people to figure out what's going on. A model getting stronger as it goes, so the predictive power is increasing. A fanned pad of a nonlinear model, and a model getting weaker, so the predictive power is decreasing. Just these are good to practice to know what you're looking at. This is a good residual plot. This shows it's appropriate. It really has no pattern to it. Don't overlook at them. Usually just give a quick scan. You're like, nothing much going on there. This one has the outlier again. So this shows, except for one point, this model is getting weaker. If you notice here, it's tight at the start. To see if a model is getting weaker, you simply draw the vertical bands. And remember, this is a residual plot. And you take and you draw the vertical bands here by doing a band, a band, a band, and a band. And it looks like the model is getting weaker. You don't want to see it spread out more. What you want to see is you want to see the bands stay about the same. As in, if you were to draw bands, you'd have about the same thickness, which can be seen in the original plot. So you want to see about the same thickness throughout. So that's a model getting weaker. Predicted power is decreasing. We see a decrease in predicted power right there. That's got it. We did all but a few questions, and that's not a bad one. It's like not a fun one. And that one's a tough one. Not tough, but a lot of work. Well, with that, I'm going to go eat a sandwich and go to class. Bye for now, everyone. Bye.